All right, this is the final video on scientific notation that we're doing today. We are going to get started by talking about what it means to just multiply and divide with numbers written in scientific notation. So let's start off with just a simple problem like this. We need to remember, first of all, our commutative property. The order that we multiply doesn't matter. So I'm looking at these two numbers and saying these are both kind of like coefficients, right? They're not in exponential form. So I'm going to multiply those together. And what is 3.4 times 5? Well, that's 17, right? Now I'm left with 17, right? I just combined those terms times 10 to the third. Well, this is getting awfully close to scientific notation, but we're not there yet, are we? Remember back from the previous video, our coefficient has got to be a number with just a single number in the ones place. It's got to be a number between 1 and 9.9 repeating. But here we have a number in the tens place, so this is too big. But we can reduce it by a power of 10 by dividing by 10 and turn it into 1.7. But to keep this equal, if we take a power of 10 away from here, then what do we have to do over here? That's right, we have to add a power of 10 so it stays balanced, right? We just took one of the times 10s from here and moved it over here. And this becomes our final answer in scientific notation. Yep, that's what we just said. So now we can just look at two numbers written in scientific notation. First of all, we can get rid of these parentheses, right? Because we're just multiplying. What property is that? That's the associative property. When we're doing just one type of operation, right, just multiplication, the way we associate our numbers doesn't matter. So I'm going to get rid of those parentheses. And then what property allows us to move things around when we're multiplying? Well, that's the commutative property. So we've now gotten rid of the parentheses and rearranged it. Well, we can solve for this, right? What's 4.5 times 3? Well, I don't know. Let's multiply it out and find out. 4.5 times 3. Well, 3 times 5 is really 5/10, right? It's 15 and 1. 3 times 4 is 12, plus 1 is 13. 13.5. Fabulous. So we have 13.5 times 10. How do we multiply numbers with exponents? Well, this is 10 times itself 5 times, and this is 10 times itself 4 times. So we have a total of 10 times itself 9 times. We just add those exponents. But we're not there yet. We have one task left. We've got to get this in proper notation, right? This coefficient's too big. It can't be any bigger than a single number in the ones place. So we need to get a power of 10 out of here. We're going to divide by 10, and we wind up with 1.35. But since we removed the power of 10 here, what do we do here? Well, we add a power of 10. We suddenly have 10 to the 10th instead of 10 to the 9th. And this is our final answer. So I give you a couple problems with your group to do. This is the same process, right? 5.2 times 2. We get rid of the parentheses, rearrange. 5.2 times 2, well, that's going to be 10.4. You can check that math if you want. Times, what's 3 plus negative 4? Well, that's going to be negative 1. So times 10 to the negative 1. But this isn't proper notation, is it? This is too big. It's got to be a number less than 9.9 repeating. So I'm going to take a power of 10 out, and I get 1.04. And since I took one out here, I have to add one here. And so that's times 10. What's 1 plus negative 1? Well, 0. And you honestly could go ahead and leave this out by now, right? This is just 1. 10 to the 0 is 1. So the real answer is just 1.04. And you can go ahead and do the other two. I'm not going to do that right now. All right, so moving on, we also have to be able to divide. And this really is no different than what we were just doing. We recall from a couple weeks ago, a couple lessons ago, that when we're asked to divide, that's the same thing. Fractions and division are the same thing, right? 3 divided by 4 is the same thing as the fraction 3 over 4. So the first thing I need to do is I'm just going to rewrite this as a fraction, right? This goes on top. That's my numerator, over or divided by my denominator. So that's what I've done here. And now if you recall, when you multiply two fractions, you just multiply across, right? So this is 6.4 times 10 to the third, which is what we have here. And this is 2 times 10 to the first, which is what we have here. So it's important to notice that we can just rewrite this as 6.4 over 2. That's what we've done here. Times, that's what this is doing, so times 10 to the third over 10 to the 1, which is what we've done here. Oh, I didn't finish that. So all that we're left with is just to do these two computations. What's 6.4 divided by 2? Well, we could go the long route and say, well, how many times will 2 go into 6.4? Well, 3.2 times. So this is 3.2 times. When we're dividing terms with exponents, we just subtract those exponents, right? So 10 to the 2, or 10 squared. And that's our final answer. So we'll do another one. We're going to start by rewriting this as a fraction. So what do we get? We get 4.5 times 10 to the 8th over 3 times 10 to the 3rd. So let's move on. That's what we've got here. Now we're going to write this as two fractions. So 4.5 over 3 times 10 to the 8th over 10 to the 3rd. Now that we have this, we just simplify the fractions, right? 4.5 over 3. Well, how many times will 3 go into 4.5? That goes in 1 time with a remainder of 1. We go over to our tenths, and it goes in 5 times. So we have 1.5 times 10 to the 8 minus 3 is 5. And that's it. So I'd give you a couple more problems to work through yourself. And we can go through, you know what, I'll go ahead, I'll do this top one because it's got a negative exponent. That can be kind of scary. So rewrite it as a fraction and separate them. We wind up with 5.4 over 2 times 10 to the negative 3 over 10 to the 5th. Well, what is, how many, okay, right? 2 divided by 5.4 goes in 2 times. The remainder of 1, we carry down that 4. 2.7, right? So we have 2.7 times, well, this is no different. We're still just subtracting. What's negative 3 minus 5? Well, that's going to be negative 8, right? Negative 3 to the left 3, and then minus 5 to the opposite of going to the right 5. So we wind up at negative 8. All right, the last big thing that we're going to work with is making sure we understand, like, this happens in real life. We need to be able to take situations in real life, what we're calling contextual problems, problems that use context from the world around us, and that we can solve them. So I give you this problem. The speed of light is 7 times 10 to the 8th miles per hour, and the speed of sound is 7 times 10 squared miles per hour. I ask you, how many times faster is light than sound? So I'm saying sound. When I say how many times faster, I'm saying what do I have to multiply sound by, right? Times what equals 7 times 10 to the 8th. Well, we can go back and use our inverse property of multiplication to say, hey, I recognize that this is going to be the same thing as, right? If I have A times B equals C, right? Then that's the same thing as C divided by A equals B. So 7 times 10 to the 8th over 7 times 10 squared. And that's going to give me my how many times faster? Well, what's 7 divided by 7? That's 1. And what's 8 minus 2? 6. So my what, when it says how many times faster, that's just 1 times 10 to the 6th, right? As long as you understand what we were doing earlier, this is the easy part. The hard part is just understanding what the question's asking. All right, and that's it. So hope that helps. That's the last video that we're doing here on scientific notation. Thank you so much.